Hello, my name is Dhruv Bala, and I'm a junior at Lane Tech College Prep in Chicago, Illinois. I would like to thank the Davidson Institute for allowing me to present my innovation, Sidewalk Nav. So self-driving cars are fast becoming the norm in today's society. Large companies like Amazon and Kroger are investing millions of dollars into optimizing same-day delivery. Small and medium level businesses lack the technological advancements and the financial funds to keep up with these large e-commerce giants. It has been reported that in the past 8 years, 500,000 people in these small and medium level businesses have lost their jobs. 90% of these businesses have reported that it was due to Amazon. So let me give you a personal anecdote. The other day I was with my friend and we were in Lincoln Park, the neighborhood I used to live in. And when I was there, I was taken aback because I couldn't see any of my old favorite hangout spots. For example, LP House, Hayma's Kitchen, Standard Market and Grill. They were all gone. And it got me to thinking about my favorite shop in my neighborhood of Wrigleyville, go Cubs, El Mercado Food Market. El Mercado Food Market probably makes the best empanadas I think I've ever had in my life. But the only way for this company to survive is due to their grocery store. And when I was talking to the owner the other day, he was saying that they're not able to sell quinoa at their stores because Amazon is selling this and promising 2-day delivery to their customers. So I created a localized navigation for the sidewalk using a neural network. So let me tell you about how I got to this point in my life. First, let me introduce you to Dashmobile, named after my brother. This was the robot car I developed after spending the summer of 2017 at Stanford learning physics. I built the steering system for my robot car based off of the Ackerman kinematic principles. I tested it with the famous Millikan race car dynamics and lateral acceleration behavior. I want to laugh at it now, but I really thought that this car could deliver groceries. All it did was just merely test steering principles. So that summer I went to Stanford to learn programming. There I was instantly immersed in the language of Python. So I decided to take my application up a notch. I used computer vision to isolate bicycle lanes and have a car autonomously drive through it. This took me to ICEF. I was an ICEF finalist. But the reason my application is what it is now, neural networks, is for two main factors. The first factor is that an ICEF judge told me if I really wanted to make this project elite was if I used neural networks. The second is that when I was testing my project on the roads, I learned that drivers are unforgiving and that bicycle lanes are not feasible for delivering groceries. The summer and fall of 2019 were some of the most brutal months of my life. I had to learn what a neural network was, learn how to use TensorFlow, learned how to use Google's DeepLab V3 architecture and use the dataset known as cityscapes, and then learn how to integrate the neural network system with different systems, and then to put it out on the sidewalk, only to see everything fail. Then I found a neural network expert and a Stanford PhD candidate called Mr. Sheng Li. He advised me to use the mapillary dataset. I had known about this mapillary dataset beforehand, but he was the one who truly convinced me to switch over to that from cityscapes. So then I had to train my own neural network. So there are several types of neural networks. There's object detection neural network, there is probability scores, text-based answers, and semantic segmentation. Semantic segmentation is considered the highest level of neural networks because it classifies each pixel on the image. So let me walk you through one iteration. The neural network will first take a picture from the mapillary dataset and then it will go through the neural network where it applies the filters and activates a neuron. Then a predicted image comes out. That predicted image is then compared with the ground truth image and a loss score is calculated. This loss score will then update the weights and biases of the neural network. And then another image is taken, and another, and then I repeated this step for 35,000 different iterations until I finally got an image which meets the IOU benchmark standard of 80%. Now let me show you the demo of the Sidewalk Nav neural network system. This picture is from my neighborhood. It has roads, sidewalks, road signs, fences, etc. Human brain can easily perceive this, but how does a computer know these road elements? This picture runs through my neural network AI algorithm. Now the computer can perceive this picture. Sidewalk in pink, road in purple, road sign in light blue, etc. It can classify 66 road elements with different colors. Here you see my app running on a computer. The top left is a feed from a video camera attached to my computer. The video camera is looking at a road scene. The top right is a segmented image after the picture runs through the neural network. The bottom left is a visual representation of the accuracy of my algorithm. The bottom right has the sidewalk isolated and the midpoints of the sidewalk shown in yellow dots. The computed safe steering angle is also shown. This video is my app being tested near my neighborhood sidewalk. My algorithm outputs automobiles in brown color, poles and fences in gray color, and vegetation in green color. Sidewalk in pink, road in purple. Crossing the crosswalk identified in purple and white, and human and pets in blue. I also built a mobile app on the iOS. There on the top is the video feed from my iPhone. The video feed is sent to my computer, which acts as a server. My server processes the image frames through the neural network algorithm and sends back the driving angle and the speed. My neural network recognizes humans and drives safely away from them. It recognizes crosswalks and creates a safe driving path avoiding roads. And it recognizes cars and other automobiles and maintains a safe distance from them. My app sends all the information via Bluetooth to any robot. It sends speed, steering angles, presence of humans, red lights, stop signs, automobiles, and other valuable information. Now anyone has capabilities to build a self-driving robot with my neural network algorithm and my app. As much apprehension as I have towards these large technology companies, I would really like to thank Google for making their neural network architecture open source. And yes, I need to build a vehicle, and yes, that vehicle needs to have GPS, but I've done that before. I truly believe that the first step and the most important step is creating a neural network system that functions on the sidewalks and makes decisions like the humans. I envision that all these small and local neighborhood businesses will have their own driverless systems and they can have a fighting chance against these large technology companies like Amazon. Finally, I would like to conclude by asking you to visualize and imagine the first empanada being delivered from El Mercado. I would again like to thank the Davidson Institute for allowing me to present my application, Sidewalk Nav.